to, jump in and interrupt me. I'm going to start, though, by just talking about fractions. How does the arithmetic of fractions work? Because I think it's something that you all know, but, at some point or another, you've gotten burnt on a detail, and maybe you lack a little bit of confidence in how this works. I don't know. Let's try just talk about it a little bit. So let's start with adding fractions. That's kind of a good place to start. How do we add fractions? So suppose we had 3/7 and we were going to add it to, say, 2/10. How would you do that? You're like, well, I pick up my calculator and do it. Fine, but I think it's instructive for us to not do that. Okay. Find a common denominator. So what's a good common denominator here? 70, yeah. So what I do then is I take 3/7, right? And I multiply that by 10 over 10. And I take my 2/10 and I multiply that by 7 over 7. Now, why do I do that? Because those numbers that I'm multiplying by, they're just the number 1, right? But they're the number 1 written in such a way that it serves a purpose, right? Which is to make that common denominator. What's the common denominator we have now? 70, right? 3 times 10 is what? 30. So I've got 30 divided by 70, plus what's 2 times 7? 14 divided by 70, right? So what did I just use here, by the way? I used this. I used that A over B times C over D is what? It's A times C over B times D, right? So when we multiply two fractions, what do? What's the rule? We multiply the numerator by the numerator and the denominator by the denominator, right? That's how we multiply fractions. So that's one thing. And then, of course, once we have a common denominator, then we can add these, right? So that gives us 44 over 70. And there you go. Now, you could reduce that, right, if you wanted to, but that's kind of not the point here. If you wanted to write it in lowest terms, how do you do that? You try to cancel common prime factors until you get it down as far as you can. So both of those numbers are even. I could rewrite this as 22 over 35. That's probably as far as I could go. But I don't usually charge you, let's say, points for not knowing that. That's just for your information, okay? I don't think I can go further than that. That's 2 times 11 divided by 5 times 7. None of the primes and the factorizations of 22 or 35 are common. Let's see here. How do we multiply? So I think I already answered this, but how do we multiply? 13 over 10 times minus 1 over 7. How do we multiply this? Yeah, multiply the top, right? So minus 13, and downstairs still 70, right? What if we were going to divide by? What if we had 13/10? And I don't like this notation, but I'll do it. Divided by minus 1/7. So you probably won't see what I just wrote on any test I'll ever make. I refuse to use this divide by symbol. Instead, what I would write is the following. I would present this problem as 13/10 divided by minus 1/7. It's really just a question of mathematical taste, but that's how I write it. I don't like this divide by symbol. It's easy to miss it. It's really hard to miss that giant divides, that giant bar there. How do we do this? What's the rule? Change the what? Keep change flip? Oh, you guys know some kind of like secret language or something. It's it's like some mathematical Da Vinci code or something. I don't know. I mean, you're telling me to do that, right? Yeah. Okay. It's the same but different. That's what my 7-year-old always says. It's like he's always like, it's exactly the same, but it's different. It's like, I'm sure you know what same means. But for him, that's actually a reasonable saying. Like, it's the same but different. He'll say something like, more along the lines of like, it's completely the same, just completely different. It's like, no, you can't say that. He is 7 though, and kind of cute, so I let him get away with it. Anyway, so, oh goodness, what is minus 7 times 13? It's 70 plus 21, it's minus 91. And downstairs we've got 10, right? So like, what's the generic algebra pattern we're using here? It's something like this, right? If we have A over B, and we divide that by C over D, it's equal to what? It's equal to A times D divided by B times C. So I think of it this way. The denominator of the numerator becomes the numerator of the denominator, and vice versa. So like the denominator of the denominator becomes the numerator of the numerator. Like it's kind of like, I mean, it's a game of sorts, I suppose, but there's one of the games we can play, right? What if we just have a fraction times a number? Like, what if I've got, 100 times 1/3, how about 1/4 minus 1/5? How would I do the arithmetic here? Do what? Do fraction sign of parentheses first. Hey, that's one way we could do it. So hey, I'll do it that way. So we'll do it we'll do it that way. That's one way. So make a common denominator. So there's like 1/4 times 5 over 5, right? Minus 1/5 times 4 over 4, right? We'll make a common denominator of 20. And what will we get? That's going to be 5 over 20 minus 4 over 20, which is what? What's 5 minus 4 is? Oh, so that's just 1/20th. So how's that work? We just have what? That's the same as 100 divided by 20, right? And what's that? That's 5, yeah. Now, nothing wrong with that. Completely fine way to do it. But can you guys tell me another way to do this? You say multiply the what? So you're saying at the start we should use the distributive property. I'm just going to put some words in your mouth. That's okay. I mean, I know you guys don't like to use these words, like, and I didn't either when I was in your place. Like, math professors started talking about commutative and associative and distributive. I was just like, shut up. How do I do the problems? And it's literally my my internal thought process. I fought learning those words. I fought and fought, and finally I succumbed and I learned the words. But for me, a long time, I was just looking for, new rules to the game like this. When I learned this, I was like, what? No, see, this is neat. Because if you don't know this and you're trying to work problems, sometimes you can still get around it not knowing this, right? But every little thing like this, is it all comes together, right? Let's see here. So this is 100 times 1/4 minus 100 times 1/5. That's the distributive property, right? The distributive property says that A times B plus C is AB plus AC. This is distributive property. And so what's that? That's 100 divided by 4, which is what? 25, right? And 100 divided by 5, which is 20. So what do you know? We still get 5. Sometimes in your another discipline, maybe like literature or history or something, you might hear a professor say something like, well, we can agree to disagree, right? There's more than one interpretation, right? Depending on how you look at the author's life and so forth and so on, or circumstances of history, blah, blah, blah. And here, I'm sorry, we cannot agree to disagree. The answer is 5. It is not up for grabs, right? It is 5. We're stuck with it. So math is kind of annoying in that way, right? Sort of countercultural to other disciplines these days to have an absolute answer. But there are subtleties in what constitutes a direct proof, though. So as you get higher in math, there start to be more nuances. But anyway, what else could we think about? Something that'll catch you guys off guard is something like 3 times 6 to the minus 1, right? So how do we deal with something like that? So admittedly, we've kind of left the world of fractions, and now we're kind of talking about exponent laws, but improper fraction. Oh, well, I guess the question is, what does this mean, right? What does 6 to the minus 1 mean? Oh, I know what I got you. You're asking for a different example. I understand now. I'll get back to it. Here. 31. Okay, so 31 times 6 inverse. What does 6 inverse mean here? That's going to make the answer to be an improper fraction. That's why I did that. So that's 31. What's 6 to the minus 1? That is, by definition, 1/6. And so we can write that as you requested, improper fraction as 31 over 6, right? And in my book, that's a perfectly good answer, right? Now you've been taught to write it in terms of like mixed numbers before, right? So 31 divided by 6, we do what? I mean, this is kind of a stupid use of long division. You get 5 here, right? 31. 1 is smaller than 6. That makes it the remainder, right? So that tells us that 31 over 6 is equal to 5 plus 1/6, right? So you could rewrite it as 5 plus 1/6 if you wanted to write it as a whole number plus a proper fraction. But I don't require you to give your answers in here as in terms of like that mixed presentation.
Yes, sir. I was just talking about start off with like an improper fraction first and work up from there.
If you start out with, let's see here, how about,
Like a whole number times an improper fraction.
okay, so like 100 times 17 over, I don't know, 4. Something like that. Okay, sure. So how do we do that? I mean, you got two choices, right? When you think about something with the pattern, a times A times B over C, right? There's two different ways you could look at that. You could look at it as A over C times B, or you could look at it as A, well, A times B over C. Sorry, I'm kind of being dumb here. What I'm trying to say is 17 over 4, well, that's kind of a pain, right? But it's much easier to look at this as 100 over 4 times 17, right? So if I have to do the arithmetic here, I would prefer to shift the 4 over to the 100 like that, and then that's, you guys told me a second ago, 25, right? So now 25 times 17, well, I don't know. If you got 16 quarters, how much money do you got? $4, right? So if you got 17, you got 425. It's 425. Oh, I'm sorry. I was talking about change. We don't have change anymore, right? I remember change. We should bring back change again, you know? Change we could believe in. Let's see here. Okay, so where was I? I think that's a good sample. The other sort of problem that might be good for me to just spend just a second on would be something where we've got more than two fractions, right? Like, what if you have something like, 1/12 minus 3/4 plus, I don't know, like 2/8. Right? And, and let's make it an equation for a change. Put an x in here, and that's equal to 3. What would be a smart way to solve this equation? Solve for x, right? I totally agree with that.
Subtract the two first fractions.
Well, I'm just gonna say something. I mean, we'd like, the way to make life most easy here is to get rid of the fractions. How can we turn fractions into whole numbers? We're working with an equation, right? So we have license to multiply it by a non-zero number. What number should we multiply this by to make this an easier problem? You have 12, you've got a 4, you've got an 8. Multiply by 4. We still have 4/12 then, right? Multiply by 3. What's the least, what I'm asking you is kind of a sneaky question. What's the least common multiple of 12, 4, and 8? Least common multiple. 2? That's the least common divisor, I think. Least common multiple has to be at least as much. Oh, what is the least common multiple? I need to give you guys some examples. Least common multiple of 2 and 3 is 6. The least common multiple of 10 and 2 is 10. The least common multiple of 10 and 3 and 5 is 30. I heard a 24. I like 24. 24, if we multiply by 24, 24 over 12, 2. 24 over 4, 6. 24 over 8, 3. It kills all the fractions. 24 is the least common multiple. Very good. So I say multiply by. Now you're like, I mean, you could also just multiply by the product of the denominators. That will also work. It's just going to make you multiply by a stupidly large number, right? So it's like a better practice to multiply by the least common multiple. to keep the numbers small. Technically, you could also just multiply by 12 times 4 times 8. It would also work. But what is 12 times 4 times 8? It's a big number, right? 24, not so much. So multiply by 24. We got 24 times 1/12 minus 3/4 plus 2x over 8, right? Equals 24 times 3, which is what? 72. And then we have to use the distributive property, right? So we've got 24 over 12 minus 3 times 24 over 4 plus 2 times 24 times x over 8 equals to 72. Can we simplify these fractions? I think we can, right? So 24 over 12 is what? It's 2. 24 over 4 is 6. 3 times 6 is 18. And 24 over 8 is 3. So 2 times 3 is 6. So that gives us a plus 6x equals 72. And so what do we get? 6x equals to 72 plus what? Yeah, plus 16, right? Because this gives us a minus 16 on the left-hand side, so we add 16 to both sides. Tell you what, let me put one more step in there, because that's this. You know, guys, you have to stop me. Sometimes I get in my pre-calculus mode, where we skip more algebra steps. Here we're supposed to put more, and you got to stop me if I don't put them down. So this is minus 16 plus 6x equals to 72. Right? Add 16 to both sides. And did you tell me that was 88? So 6x equals 88, therefore x equals to 88 over 6, right? Oh, no. I keep... Oh, you did? Sometimes I forget to check on it. Any questions? Now, what if we had not used this trick? What if we had just dealt with the fractions and hadn't multiplied? Could we still solve the problem? Yes. Yes, we could, right? It might actually be instructive for me to do it that way for you. So suppose we instead looked at it. I'm just going to do the same problem again, but I'm going to do it a different way. I hope you won't get mad at me. My children get super angry at me when I explain them more than one way to do a math problem. So I know I'm running a risk here. Sometimes people get, I already know how to do that one. You go to the next one, you know. So the 2x over 8 simplifies to what? That's x over 4, right? So 3 minus 1/12 plus 3/4, right? So that says that x equals to what? I have to say, I think this particular problem is easier the second way I'm doing it. It just so happens, right? I think it's looking like it's a little bit easier, but I don't know. It's hard for me to gauge exactly. We had a kind of detour of about 2 minutes to talk about what a least common multiple was, you know? So that kind of clouded the efficiency of the other approach. But then we distribute, right? So this is what? 12 minus 4/12. Ooh, maybe it's still got some nastiness over here. Plus 3, right? Because 4 times 3/4 is what? 4 times 3/4 is just 3 again, right? 4's cancel. And then what? Well, that's 15 minus 4/12, and I think this might have been part of what you were asking about earlier. You wanted to see this kind of calculation, actually. So to make this subtraction happen, we either need a calculator, right, which is fine, or we can do this. This is 15 times 12 over 12 minus 4 over 12, right? Which is 15 times 12 minus 4, all divided by 12. What's 15 times 12? 150 plus 30, right? So it's 180 less 4. 176 divided by 12, I think. Like, oh no, we have different answers, right? But what is 176? How does it relate to 88? Yeah. So this is 2 times 88. And by the way, 12 is 2 times 6, right? So in fact, it's the same answer, just it's a different presentation of the same number. So if we reduce that fraction, we get back to the other one. Okay, let me take a second here, unless there are other questions, to look at section 1.6 for a second. Try to find us some problems. So the first question is 1.6.17. The question is, find the distance between points on a number line. All right. So we'll start with that question. We're good on this?
Can you do one since I wasn't here? Just like
Oh, all he was doing was just like solving the linear equations again, but with fractions. So I don't think you missed much. It's pretty much just, really I did these same kind of problems day one. I haven't covered a new technique or anything when you were gone.
homework too.
Yeah. Let's see here. So how do you find the distance between two numbers on the number line? What do we do there? So I'll do an example of that. So if I've got, I'll just tell you generically speaking, if I've got this is A and this is B, and I want to find the distance from A to B, what we can do is we can take the absolute value of B minus A. So, more specifically, so I'll actually put in some numbers, right? So if we had, say, -1 and 4, how would we find the distance from -1 to 4? And that health department is busy today. Let's see here. 4 minus, we got to be careful, right? So absolute value of 4 minus A minus 1, right? Which means that 4 plus 1, right? So it's the absolute value of 5, which of course is just 5. And I mean, that makes complete sense if you look at the number line, right? Because it takes 1 to get over to 0, right? And then you got 1, you got 2, and you got 3. So it takes 1, 2, 3, 4, 5 units of distance to get from -1 to 4, right? So the quirky way negative numbers work, it's all accounted for in this formula. Let's suppose we find the distance from, say, minus 11 to minus 2. So we should take the absolute value of minus 2 minus a minus 11, right? By the way, it doesn't matter if you confuse which is A and which is B. Like, it doesn't matter, because there's a convenient truth about the absolute value. This is equal to absolute value of A minus B. In other words, the distance from A to B is the same as the distance from B to A. That makes sense, right? Shouldn't make a difference. And it doesn't. So how's this work out here? Minus a minus 11 is what? Plus 11, right? Yeah. So we got absolute value of 9, yeah. Which also is known as 9. Yep.
Only for that, I would write in the black if possible, because it's harder for it to show up in that. You can see it, but it's kind of
Yeah, you won't see it in there. I think it'll show up when we're looking on devices later. Black is always better, though. It is true. The green, yeah. Hopefully it'll be okay, because I like my blue. But the green, I try not to write anything too important in green. It's just hopeless. The green markers are just sad, which is unfortunate, because I love green. All right, I don't think this is helping you guys. Let me go on. So we have until when? I'm trying to remember. 2:40? Okay, good. Let's see here. So can you guys tell me what are the properties of absolute value? What algebraic steps, what algebraic things do we know about the absolute value function? Well, I'll tell you. These are the things we know about absolute value. So here's some fun facts. So first of all, the absolute value of A times B is equal to the absolute value of A times the absolute value of B. In other words, the absolute value of a product is the product of the absolute values. This is sometimes nice to know. If we have the absolute value of a fraction, it is the fraction of the absolute values as well. I don't know if we'll need this in here, but it is, what is it? Oh, good. I approve. Let's see here. Absolute, no, you will. There you go. So shut up. Absolute value of A plus B is not equal to the absolute value of A plus the absolute value of B. Not usually, anyway. But what we can say is that this is less than or equal to the absolute value of A plus the absolute value of B. This is called the triangle inequality. I don't know if we'll even need that in here. I'm just telling you it's something we happen to know. So here's one that is sometimes useful, though. If we have the absolute value of A is less than C, all right? And for convenience, I'm going to say where C is positive. Then this inequality, if the absolute value of A is less than C, then what that is equivalent to, you can unwrap that, exchange it for the following. This is equivalent to minus C less than A less than C. It's important that that's less than. If it's greater than, it's not like that. It's more complicated. All right? I will, in fact, just to give you both at once here, if we have the absolute value of A is greater than C, right? Where c is greater than 0. Then what that gives you is that either a is less than minus c, or a is greater than c. So I meant to write that in blue, but oh well. Have you guys graphed the absolute value function yet? I don't think you know what a function is, right? Somebody talked about it, but we'll talk about it again eventually. I think that's a pre-calculus algebra topic, actually, so I should behave. We'll mostly focus on expressions in here. Okay, so let me put this into practice with numbers and a variable. So example, if we wanted to solve the absolute value of 3x less than 1, solve the absolute value of 3x less than 1, then that would give us minus 1 less than 3x less than 1, right? And then how do you solve that inequality? All you got to do is divide by 3, right? If we divide by 3, we get minus 1/3 is less than x is less than 1/3, right? So we could put a box around that and say that's the answer, right? That would be the answer in terms of just inequalities. I mean, that's a legitimate way to write the answer. If I asked for the answer in interval notation, how would we have to write it then? What would the answer look like in interval notation? Hmm? Oh, you're thinking of the set builder notation? And that's fine. Hey, that's fine. It's almost kind of like this, right? I mean, it's like x such that, I think you're going to tell me this, right? So that would be the answer in set builder notation. That's what parentheses one, yeah. Right. Right, and they're definitely these kind of parentheses, right? Because the 1/3 and the minus 1/3 are not included, right? To change these to brackets, if we had instead had absolute value of 3x less than or equal to 1, then it would, what's that? Oh, this is the so-called interval notation. So when a math professor asks you for your answer in interval notation, they want this kind of answer. There really are three competing ways to, well, four. There's kind of four competing ways to write answers, right? The one is just to put a box around the inequality which describes the solution set, right? Like I have the red box, just garden variety, like that's pretty much as simple as you can make the inequality. There's my answer, right? It's a good answer. The set builder gives the answer as a set. It's the x subject to that condition. And the interval notation is yet another way to express that same set of real numbers. We have one other way, which is graphical, right? We could also use a number line to express the answer. And the number line would look something like, well, kind of like this, the interval, right? You know, that x is somewhere in there, right? Kind of looks like a TIE fighter a little bit, but cabin's too small. Now, in contrast, right? What would happen if instead we had the absolute value of 3x greater than or equal to 1, let's say? That means what? That means either 3x is greater than or equal to 1, or minus 3x is greater than or equal to 1, actually. So, I mean, I didn't actually write that right above, but that's the logic. When we're solving an inequality, like this is, remark. Most of these rules I'm sharing with you, most of the rules I'm sharing with you follow from this just general observation. The absolute value of A is equal to plus or minus A. So when I'm solving an absolute value inequality, I can think about the two cases, the one for the plus, the one for the minus. So I have to think about these two different cases, generally speaking. It just so happens that one of those cases is extraneous in the case of less than. Well, that's not the way to say it. They can both be fit together in one inequality, like I just did right there. All right, so what do we do there? We've got x greater than or equal to 1/3. And this is, if I divide by minus 3, what happens? Right, when I divide that right inequality by minus 3, greater than or equal to flips to less than or equal to, and we get x less than or equal to minus 1/3. Now, can a single x satisfy both of those? Certainly not. Those are distinct cases. So there's two separate cases that solve this inequality. On the number line, we could look at it like this. So here's minus 1/3. Here's 1/3. And so we've got this way, and we got that way. Let me use some color coding here. Say this is x. And I'm going to redo the color of that other one. I'm going to use green. Very dangerous. They're not the same x. We can't have both of those conditions at once, right? Those are two separate cases. But both of those cases are in the solution set. And so in interval notation, the solution is minus infinity to minus 1/3 included, union with 1/3 to infinity. This is the so-called union, is what we use to glue two sets together. Right? Let me talk about another one of your problems. Let's see if you guys can help me figure it out. What if we want to solve the absolute value of x equals to minus 3? Did I ever tell you how we defined the absolute value of x? I don't know if I actually have I should carefully define that in here, shouldn't I? I'm not sure I did. Just in case I didn't, here's the definition. Absolute value of x is equal to, it's just x if x is greater than or equal to 0. It's minus x if x is less than 0. And I mean, I can express that sort of glibly as just saying x is absolute value of x is plus or minus x, where the plus or the minus is chosen to force the absolute value of x to be what? To be either positive or 0. So by construction, absolute values are what? They're non-negative. Like absolute value of 10 is 10, right? Absolute value of minus 10, still 10, right? So can you solve the absolute value of x equals to minus 3? I hear a no. So what's the solution set? X equals to negative 3. But if I put x equals to minus 3, then we've got absolute value of minus 3, which is 3, which is not equal to minus 3, right? So like that doesn't work. And your heart's in the right place, right? But no, we can't do it. The thing is, another property of absolute value, which I really should have written, is this, that the absolute value of a is greater than or equal to 0. The absolute value of a is greater than or equal to 0. So if somebody asks you to solve an absolute value equal to a negative whatever, you have to say, no, can't do it. You can't do it. So the solution here is no solution. No solution is the solution in this case. What's the solution set? It's what's called, well, mathematicians usually use this notation for it. It's like a circle with a slash through it. This is our notation for empty set. The empty set is the set which contains no elements. Another notation would just be like curly brackets like this with nothing in there. It's the empty set, set with no elements. So I talked to you about the kind of the hard thing, which is solving inequalities. What if we wanted to solve an equality using absolute value? Could we do that? Because I think we have some problems in the homework kind of like that. Yeah. So suppose you wanted to, I'll do it over here. So, moral of the story here, watch out for when absolute value is greater than something. It breaks into two cases, right? Be on guard for that. Okay, so another example. Suppose we want to solve the absolute value of 3x minus 8 equals to 2. How would we solve this? Let me kind of put a little side note here. If we have absolute value of a equals to b, right? Then that means that plus or minus a equals to b, right? But what happens when you multiply that equation by 1 or minus 1? See, this implies that it's just the same to say a is equal to plus or minus b. Like, think about it. If it's plus, you can move the plus to the other side. If it's minus, you can move the minus to the other side if you think through the cases. So what I'm trying to tell you is if you want to solve 3x minus 8 equal to, absolute value of 3x minus 8 equal to 2, the easy way to, what's that? Add the 8, eventually. But first, we need to think about 3x minus 8 equals to plus or minus 2 is what I'm trying to advocate for here. Now, if you guys are not comfortable with the plus minus notation, we could also break it up into two separate cases and do one at a time. But I think this is going to be okay. Now you guys may teach me otherwise, but I don't know. So 3x. Now we'll do what you said. You said add 8, right? Add 8. So of course the 8's cancel, and we get 3x equals to 8 plus or minus 2. And what's that give us? That gives us divide by 3, right? You guys agree? Divide by 3. Eight plus or minus 2 divided by 3. Now, at this point, I'll investigate the plus and the minus case separately. So this gives us 8 plus 2 over 3, or 8 minus 2 over 3, also known as 10 over 3, or 6 over 3, which of course you could write as 2, right? So it's either 10/3 or 2. Oh, we could also split it up and do 2 separate cases, like, sure. That's how you used to do it? That's how they taught you? They just like to make you guys right. So we could solve this, and we could also solve this. And so we get 3x equals to 10. We get 3x is equal to 6. We get x is equal to 10/3. We get x is equal to 6/3, which is equal to 2. I mean, they're pretty equivalent methods. You could go either way. Like, certainly, if that's the way you're comfortable doing it, do it that way. It's fine. I'm just sharing this plus minus with you. It's sometimes helpful when you're in more complicated algebraic situations and you want to keep track of cases. Just to give you a flash forward into the future, 2 semesters from now, when you're in pre-calculus trigonometry, you can write the formula for cosine. A plus or minus b is equal to cos A, cos b, minus plus sine A, sine b. So like this plus minus notation is like super labor saving for like writing down identities, which are very similar for plus and for minus. It's worth introducing into our lexicon of notation. But if it's distracting to you, do it the way, what was your name again? Steve. Steven? Okay. Not Steve, Steven. Hmm? Yeah. Okay. Yeah, my dad technically was Steven, but he always go by Steve. But you're Steven and you go by Steven. You don't care? Oh, okay. All right. Okay. I still have to come up with more movie choices for you. I'm going to find them. I did work it into the video. You know, I don't know if you noticed, but let's see here. Ooh, now this one. Here. This homework problem, a little bit different. Now, I'm not working your homework problems exactly. I'm working problems like your homework because I don't want to deprive you of the joy of doing your own homework, right? That would just be bad. I might, oh no, I've erased it. Now we'll never know what distance is again. No. All right, so what would we do if we were faced with something like absolute value of 3x plus 1 plus 2 equal to 20. So what do you want to do in this kind of situation? Subtract 2? Subtract 2? Okay, so I'll take that. So you're saying trade this problem for the kind of easier problem to think about. Absolute value of 3x plus 1 equal to 18. Right. Now at this point, we can either do, we can divide and conquer the 2 cases like Stephen was suggesting, or we can use plus minus notation. Votes for plus minus. Votes for 2 cases. No, I'm sorry. Well, now I have to do both. All right. So, let's see here. So 3x plus 1 equal to plus or minus 18, which means that 3x is equal to 1 plus or minus 18. Is that right? If I bring 1 to the other side, I got to make it what? Yeah, minus 1. Right? So x is equal to minus 1 plus or minus 18 over 3. Which means x is minus 1/3 or 17 over 3. Oh, I can't do math. What's minus 1 minus 18? Is it 1? I mean, is it minus 1? No. What's the first one? Negative 19, right. Now, if you don't like the plus minus, we could have... So did they teach you... Now, Stephen, I'm curious. Did they teach you to do this? Or did they teach you to put the minus on the other side?
You put the minus on where the 18 is.
Where the 18 is... Yeah, that's good, because, like, I mean, that's logically equivalent, but this causes problems, what I wrote, right? So it's better to put the minus on the other side with the 18, right? That makes life easier. But, I mean, technically it's the same thing. So this gives us 3x equals to 17, or 3x equals to minus 19, which is x is 17 over 3, or x is minus 19 over 3. I mean, honestly, folks, like, it's the same trouble. I mean, you go either way. Just be sure you got 3. You do make sure you have 2 solutions to these, right? See if I can find one that's got a different flavor to it. Well, I actually think I've shown you an example that's pretty much like every problem in this section 1.6. So I think we're pretty much on track, and so I think this is as good a place as any to stop for today. So thanks, guys. You can hit if you...
What is it, red button on the side?
Yeah, the red button on the side.